Okay, and that's now onto the quotient rule. So the quotient rule is similar, where we're going to have a formula that we are given for finding the derivative of one function divided by another. This formula, as you can see, is even more involved, right, than the product rule. And because of the minus in the numerator, the order does matter. We cannot flip the order of the things in the numerator. So f is the numerator, g is the denominator. The derivative will be the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. That's just a lot to remember. So there is a helpful mnemonic that I learned way back in the day and it's still used. So I'm not sure if this is exactly how everybody spells it, but this is the mnemonic that I have heard over and over again. Low D high minus high D low over low low. And so the D, that means derivative. Low would be the denominator, high would be the numerator. So low D high means denominator times the derivative of the numerator minus high D low, numerator times the derivative of the denominator over low low, denominator squared. I've also heard low D high minus high D low, square the bottom and away we go. So you could use that if you prefer. Okay. So in terms of simplifying, because we still have to do that, when simplifying, depending on the situation, you may want to look at factoring out the lowest power in the numerator when you're done with the first step, the low D high minus high D low. And I will show you, I think I've got an example of that coming. And if I don't, I think we do, so that's good. All right, so here we're going to go ahead and find the derivatives of each of the following functions, and we're going to simplify. So you could see I have a quotient in this first problem, and I'm going to point out that I can't actually do the division. In other words, if this thing only had x cubed down there, then I could divide each of these terms in the top by the x cubed, and that is going to be the better way to go. Trust me, the quotient rule gets complicated. It's a lot of algebra. But in the situation that I'm in with the x cubed plus 4, I can't do that. It's not going to help me. I'm still going to have these three quotients. So I'm kind of stuck using the quotient rule. And again, you're going to want to check that. If you can simplify it and get out of the quotient rule, do it. All right, so we're going to start with low D high. Low D high minus high D low. So you can already see the algebra that I'm going to have to be simplifying, so over low low, in order to get this derivative in simplified form. So like I said, if avoiding the quotient rule is an option, then you should consider doing it, because otherwise you're just doing a lot of algebra. The other thing I want to point out is please make sure you're using parentheses. Sometimes I'll see people just write x cubed plus 4 with no parentheses and then times 2x plus 2, which means only the 4 would get distributed. So you need to make sure that you're using parentheses. Okay, So now we're going to work on simplifying this. It's just a matter of multiplying out our different factors in the denominator. I said denominator, didn't I? The numerator. It's hard for me sometimes to do math, like write one thing and say another thing. All right, I'm going to put parentheses here so that when I distribute my 3x squared, I'm remember to also distribute my negative sign. All right, so then it's just a matter of kind of combining like terms. I have a 2x to the fourth minus a 3x to the fourth. It looks like I have a 2x cubed minus a 6x cubed. Just have a minus 9x squared. And just an 8x. And an 8. So that one wasn't terribly algebraically gross, but it certainly does take a little bit of work. Okay, so go ahead and try the second one. Press pause on the video, see what you can do. All right, I applied my low D high minus high D low over my low low, and really nothing combines there. I just kind of distribute my 2t, and that's pretty much the end of that example. So one more example, and that would be to find all the x values at which the tangent line to this curve is horizontal. So here it is again. We talked about this in a previous lesson. Horizontal tangent line. What does that mean? It means that the derivative is equal to 0. So you're going to need to find the derivative first and then set it equal to 0. So go ahead and work on finding your derivative and then unpause the video after that and we'll do the rest of it together. Okay, so once again, I followed my quotient rule, distributed and simplified. And now I'm looking at x squared plus 4x plus 1 over x plus 2 squared as my derivative. And I want to know when is that going to be equal to 0. So when you have a rational function and you're setting that equal to 0, you don't really care when the denominator is 0 because that's when it's going to be, the function will be undefined. You care when the numerator is 0. So what we're really trying to solve is x squared plus 4x plus 1 equals 0. It's this part right here. Now, quick check will tell me that that's not going to factor. I can't factor x squared plus 4x plus 1. So I think I'm stuck in quadratic formula land. So we'll have -4 plus or minus the square root of 16 minus 4 all over 2. And we'll just simplify that a little bit. So I've got 12 under the square root, which of course is 12 is 4 times 3, so I can square root the 4. And then if I just divide the 2 into both of these, it's got to be both, I'll have -2 plus or minus the square root of 3. So it looks like those are going to be my x values where my derivative is equal to 0. Last but not least, I said this as we were going through these examples, but I'm just going to remind you one more time. Do not blindly use the quotient rule every time you see a quotient. So in this particular problem, this is a great example. I have only one term in the denominator, a monomial. So we can divide each thing in the numerator, each term, by this x to the 1/2, and then just take the derivative term by term. It's so much quicker. So I am going to rewrite this function term by term divided by x to the 1/2, and then just use my rules of exponents. Wow, that's a much simpler function. So when I go to take the derivative, I just have 1 plus 1/2 x to the negative 1/2, which is 1 plus 1 over 2 root x. Done. Very straightforward. As an example, or I'm not even going to finish this problem. I'm just going to show it to you. Let's say I decided, you know what? The quotient rule exists for a reason. I'm just going to use that. So now I'm going to do low, D high, minus high, D low, all over low, low. Do you see what I mean? I'm not lying. Just because you have a quotient rule doesn't mean you should use it. Okay. Always think about, is it possible to simplify first? Because this looks awful and this was super easy.